In this introduction video I will explain to you all the source code changes we made to SolidCP in order to run SolidCP on Linux. So let's first have a look at the topics. We're going to discuss the migration from Web Service Enhancement 3 to VCF, core VCF of the web services. And then next we're going to have a look at the addition of the REST API to the web services. And then we're going to look at the modifications that were necessary for running SolidCP on .NET 8. And then we're going to look at new providers for Unix, new provider assemblies for Unix. And then we're going to look at the installer. All the modifications we had to make in order to run the installer on Linux. And then we're going to discuss a new feature I introduced to integrate the enterprise server into web portal, so it's running faster. And in the end we're going to look at the support for SSH tunnels to the servers. Okay. Okay, let's have a look at the source code. We did replace the Web Service Enhancement 3 web services with VCF. And in order that we also can run on .NET 8, we need to use core VCF, because core VCF is running on .NET Core and VCF is only running on .NET Framework. And then we made an assembly SolidCP build that auto-generates VCF classes from the old VC3 proxies classes. And then we made an assembly SolidCP web services to support web services, VCF web services, and an assembly SolidCP web clients to support VCF proxies. So let's have a look at the code. We're going to look into Visual Studio Code because it uses less memory than Visual Studio, and on my laptop I only have 4 GB, so we need Visual Studio Code. Okay, first of all, let's have a look. For example, enterprise server, we can see we have all those VSE3 web services with the suffix of ASMX. And now we want to run them on .NET 8 on VCF. So what we did, we have this project here, SolidCP build, and this project has one class. It's a source generator, this class, and it examines the compiling project for VSE3 web services and generates VCF classes and VCF client proxy classes that are needed to run those services under VCF. This is just a source generator. Here's a source generator web services, and it just examines the model. It looks for the classes for web service classes. Here it looks for web service classes, and then it generates new code, and it does use it for generating code. It uses those Razor templates to generate the code. We can see here, for example, the service class. You see here it has this attribute. It's a class, and it inherits from the old VSE3 class, and it implements the interface of the that we define in this file here, and then it generates those classes. We can have a look at an example of such a class. The classes are generated here in Enterprise Server project in the folder Web Services, and in this folder SolidCP build Web Services. And here are all the generated classes. For example, we can look at this one here, ES Backup, and there's some attributes here, and then this is the code contract, the service contract interface here with web methods and web get attributes for REST. Those web invoke and web get are used for REST. It's the URI templates for REST access, and then operation contract is used for the service contract. And then we have a class here, ES Backup, that implements this service contract and inherits from the old VSE3 class. This is the old class we had before, not the generated class. That's this class here. From this class it inherits. And then we have also the client classes. The client class, it also has inherits from the service contract, and it just invokes. It inherits. This is client class for the assembly client. We have different bindings that we support, and one binding is assembly binding. The assembly binding does not call a web service, but it just loads the assembly and calls the method through reflection. So we can embed Enterprise Server into the web portal without calling web services. And this is this class here, the assembly client, which just inherits from SolidCP web clients, client assembly base, and it just calls invoke to call this method. And then we have the normal client to call a normal VCF web service, and it inherits from this class here, client base, from this class here, client base, and this class has type parameters, the service contract and the assembly client above, and it only calls the methods on the client method of the base class, the client property of the base class. So this is yes, this is what SolidCP build generates, this source generator, and then the generated classes, they are in this folder, and here we have the client project in this web service subfolder in Enterprise Server. We have the Enterprise Server client project. It's not anymore in the here in this folder is only a project that imports the above project, and here is no code anymore in Enterprise Client Server Client folder, but the code is here, this auto-generated classes. And so this project is the Enterprise Server Client, and we have here it defines a compiler constant client, because the generated classes, they have server classes and client classes, and the server classes, they have a preprocessor condition not client, and the client classes, they only compile when the compiler symbol client is defined. So the client classes only get compiled through the client project here, through this project here, and the server classes, they get compiled in the ordinary enterprise server project. Yes. So in order to support this, we have two projects that serve as support, so this works. And this is SolidCP Web Clients and SolidCP Web Services. Let's have a look first at SolidCP Web Services. This project compiles in two frameworks, in .NET 8 and in .NET 4.8. You can see this here. It's compiled against .NET 4.8 and .NET 8. And we have the host factory, and actually this project, it has two versions, one for .NET 8 and one for .NET 4.8. And for .NET 4.8, the initialization code is this class here, the startup class, and it starts all the web services, and it creates routes to the service host factory for different types of APIs, URLs, and we have different types of URLs. I'll look at web clients first because there it's more clear. We support different URLs for different VCF bindings, like those are the protocols that are supported: basic HTTP, net HTTP, VS HTTP, basic HTTP with secure HTTP, and then net TCP over SSL, NetPipe, and REST, and GPRC, but actually GPRC support is not implemented, and then assembly protocol and SSH tunnel. Those are the supported protocols, and you can specify them in the URL. If the URL ends with basic, then it's a basic protocol. If it ends with net and with all those values, then it selects out the given protocol. And this class here is the client base. It's the base of all client proxies, and you can there's a property protocol URL where you can assign the URL, and when you assign the URL to the client proxy, it automatically sets the corresponding protocol to the suffix of the according to the suffix of the URL. And we have a property protocol here where you can change the protocol that the proxy uses. I'm going to show this more later on, how this works in practice. So we have different protocols, and here below there's a method, a property here, client. This property chooses the proper client to use for the proxy classes according to the protocol we use. And here we have, if it's VCF, we are going to use the VCF bindings and initialize the VCF bindings. Yeah, and here are the different VCF bindings are selected for the proxy client. And then we have gPRC, but this is not supported at the moment in assembly. If the proxy is an assembly proxy, it chooses the assembly client, and so on. And then there's also support for authentication, and for this we have no, this is certificate validator. This is something different. There's also an assembly loader that is loading assemblies, and this assembly loader is used for the assembly binding. But you can specify external probing paths in the configuration, in the app settings of the web config, and then the assembly loader is looking for assemblies in those external probing paths. Then we have a message inspector for the support of SOAP headers. SolidCP's server uses SOAP headers in the VSE3 classes, and so we need to support those SOAP headers, and we do this with a SOAP header message inspector. And this is on the client side, and if the proxy has a SOAP header field that is set, and or the client credentials are set. Also, the client credentials are passed with a SOAP header, because core VCF does not really support VCF authentication. So we supply the client credentials with a SOAP header, and so we set the SOAP header here for the SOAP header and for the credentials. And then, yes, and on the server side we also have a message inspector that's reading the SOAP header, and this is the SOAP header message inspector on the server side, and it just examines the message, and then it's reading the SOAP header or the credentials SOAP header. Yes, and then it when it has the credentials SOAP header, it calls the validator username. It creates a class username password validator. This is this class here, and it calls validate on this class to check authentication of the message. And this is actually a username password validator, VCF username password validator, but problem is core VCF does not support this as it should, and so we call it from the SOAP header message inspector, this validator. And what it does, it looks at the policy of the web service, and then it calls validate server here below, one of those two functions, validate server or validate enterprise server, according to which project we are in, and it validates the password and the username in enterprise server or in server. And enterprise and enterprise server, they set those fields here, so the validate method can validate the credentials. And yeah, we have these classes here that start up the web services. This is for .NET Core, for Core VCF, the start method for Core VCF. it just initializes Castro, and then it creates the listening web services. Here all the bindings of the different URLs with the different APIs. It creates all the VCF bindings to listen on those to those web services. Yes, and we have a policy attribute here. This is the policy attribute where you can set the policy for a web service. And there are three different policies. One is enterprise server policy, is used for enterprise server with authentication, and the server policy is used for server authentication on the SolidCP server. And the common policy is if you just want to be the web service to use encryption but no authentication, you use the common policy, so the web service is encrypted but has no user authentication. And you can see in the web service classes, for example, here let's have a look. They declare this policy tag, and it's imported from SolidCP web services, this policy, and we have here enterprise policy. Yes, because it's a class in the enterprise server. And we have a different one like test. It uses no policy because it's not encrypted. It doesn't need encryption because there's no policy here, because this is only test methods that don't need encryption. Okay. Yes. So this is the policy, and then we have, for REST, we have a different mechanism of authentication. We use a REST authentication manager for authentication in REST, and this is a service authorization manager also from VCF, and this is checking authentication for REST. And it's just checking for a basic HTTP authorization header in the HTTP headers. It's using basic HTTP authorization. And yes, you can look at the service host. This is the service host class for web services, and it also checks the API of the URL, and according to the ending suffix of the URL, it adds endpoints with the different VCF bindings. NetPipe binding is of course only supported on Windows. Okay. And so much for this. Okay, let's head to the next point, to the REST API. As we have seen, we could add a REST API. We have seen SolidCP build creates the REST bindings. in the methods. The service interface. Yes, here it selects strings parameters, complex parameters, and simple parameters that are passed in the query string, and then here it builds the attributes, and the query string URI template is the URI template, and it adds for the parameters, and yes, here it creates the URI. It takes the simple parameters and appends the identifier, or here it appends it in the query string. Yes, here it appends the string parameters that are of type string, and then it appends the simple parameters that are of a simple type, like integer or something, and appends them to the query string. And the rest of the parameters it applies a body style of wrapped request in order so the complicated parameters can be passed in the body of the web request. Yes. Yes, we added Swagger, so you can have a look at the API, and so you can generate proxy classes for the API, and this we can see. Let's have a look at this. We're gonna look at let's have a look at the enterprise server. Yes, we also did implement lazy loading, so the enterprise server and the server is loading faster, but it has not a huge effect on loading times, but it's a little bit faster because we put assemblies that are not needed on startup of enterprise server. We put in the folder bin lazy, so they are loaded on demand, those assemblies. Okay, so we can look here at the API documentation of enterprise server, and this uses Swagger. So we have a documentation of the REST API, and we can do the same for server. And here it's loading the description of the REST API. actually for the server component there's a small problem with the Swagger of the services, because we need to support SOAP headers, and we solved it like this, that the SOAP headers, they are just passed as a header, HTTP header formatted with JSON. A JSON HTTP header is used for the SOAP header that's needed for the SolidCP server web services. And here in this documentation it doesn't show this SOAP header. I don't know how to do it, so it shows up that it needs this SOAP header here, and this is all the methods of the REST API of the SolidCP server. And we can look at the test class here, like this method here, test echo, and we can try it out with hello, and then we can try this method, this REST method, and it crashed. Yes, so that's something I need to fix. Not found. Why not found? Yes, I don't know why. Okay, this is not ready yet, but actually here you should be able to run the REST API. Okay. Next, modifications for running on .NET 8. Actually, only the server needs to run on .NET 8, because only the server component needs to be able to run on Linux. And the enterprise server would be nice to also run on Linux, but it's not really necessary. So at the moment only SolidCP server is running on .NET 8. Enterprise server is still running on .NET framework. It would not be too hard to port enterprise server also to .NET 8. It has some dependencies on HTTP context, but not very much, only a few, and if we replace those HTTP context dependencies, enterprise server can also run on .NET 8. But at the moment we did not implement this, and it only runs on .NET Framework Enterprise Server. But if you want to port it to .NET 8, it could also run on Linux, and as SQL Server is also available on Linux, you could move Enterprise Server completely to Linux. But as we implemented embedding Enterprise Server into Web Portal, this is preferable, and Web Portal only runs on Windows. It does not run on Linux, because it uses ASP.NET Web Forms, and Web Forms it doesn't run on .NET 8. Maybe you could we could try to run Web Portal on Mono on Linux, on Mono Web Forms, but yes, I don't know if it would run stable on Mono Web Forms and the Web Portal. So it could also run on Linux, the Web Portal, but at the moment it only runs on Windows. Okay. Yes. We did move SolidCP server. All the projects in SolidCP server we moved to SDK MS Build projects. You can look here, you can see it's an SDK project, so it also can be compiled in .NET, in .NET 8, and also the projects of enterprise server also run on we also converted to SDK projects here. So all SDK projects, only the installer remains the old style projects. And it's a little bit tricky because the SDK projects, they don't really support web forms very well, and for a web forms application it's better to use the old style projects. And so web platform is also web portal is also old style web projects. Only enterprise server and server we move to SDK style projects. And also mixing SDK style projects and the old style project, it has some little problems. Most of the time it's working, but sometimes it's not optimal mixing those two. Yes. Yes, he explained already. Web services and web clients, they are dual build for Net 8 and Net 4.8. And SolidCP server also, it has two versions, SolidCP server. One version for .NET 4.8 and one for .NET 8. We can have a look at this. Here we have two frameworks, .NET 8 and .NET 4.8, and yes, for .NET 4.8, yes, for .NET Core, the output path is bin.net. And for .NET 4.8 the output path is bin. So what this means is that we have the .NET 4.8 project, the executables here in the bin folder, all the DLLs for the .NET 4.8 version, .NET 4.8, and then the .NET 8 version of the server is here in this folder by bin.net. And here we have the versions of the DLLs for .NET 8. And there's some DLLs that are used by both, by .NET 8 and by .NET 4.8, like Net Standard DLLs, and they reside here in the bin Net Standard folder. And we have here all the providers that run both on Linux and on Windows. Those providers, they are here in the Net Standard folder, and they are compiled to .NET Standard 2.0, and they reside here in the .NET Standard folder. And in order to support this, so that .NET 8 can find those Net Standard DLLs, we implemented an assembly loader, as we have shown before in web services. Here we have an assembly loader for .NET Core, and this assembly loader, it is looking for assemblies in another external paths, and you can specify those paths in the .NET configuration file for .NET 8. And this is here in SolidCP server in the app config JSON, app settings JSON. Here we have probing paths, and it's looking in a directory not relative to the app domain path. Therefore we have those two dots here, and then it looks in the next standard folder for assemblies. This is the assembly loader is looking for this setting here. And also this app settings JSON is actually the configuration for the .NET for SolidCP server running on .NET 8, and we have here the application URLs. We could also specify a NetTCP URL here, like this, localhost, and then some port. Like this, we can also configure NetTCP binding. And here's the server password, the same as is used on the web config for .NET 4.8, and then a certificate for the server to use, and we could specify a store certificate from a certificate store, or just from a file and a password. Save this. Okay, so yes, and we can see providers that are running on Windows and on Linux, like for example the bind provider. They compile against Net Standard 2.0, and the output path is in the Net Standard folder of the SolidCP server. So that's how this works. Okay, next, new providers for Unix. First of all, we had to slightly modify the given providers that can also be used on Unix, like for example this bind provider. We had to modify the isInstalled method, most of the time the isInstalled method, and this is the new version of the isInstalled method. It just looks for a process that is running named, or if it finds named in the path, paths that are specified in the path variable. If it finds a named in the path, in the environment path, and then it checks all those processes and just runs the exe of those processes with the version attribute, and reads the version of those processes, and then it checks the version against the given version we can specify here. With this, the bind provider is running for version 9 or 8 for bind, so we check for those two versions here in the isInstalled method. And we have SQL Server that's also working the same. We have here check version for Unix and for Windows, and then we check for the version. We have some new providers for Unix, but they're not yet complete. I just started the work on those new providers. One is Unix for the operating system, and it implements methods for the Unix operating system, and here it has support for different shells and service controllers. At the moment only system D is supported for service controllers, and also installers in SolidCP providers base. We implemented some facilities for operating systems. We have a class OS info that is used to distinguish the running where we are running on, like we have here all kind of methods to check for the runtime, if it's running on Mono, on Core, on .NET Framework, .NET Native, if it's running on Windows, on Linux, on Mac, on ARM, Intel, or if it's Net48, if it's a 64 process or 32 process, or the framework description. Then we have if it's running Unix, FreeBSD, NetBSD. And then OS platform is just Windows, Mac, or Linux, or something or Unix or something else. And then we have OS architecture is the processor architecture, and then OS flavor is giving us an enumeration of OS flavor. Here we have those: Windows, Mac, Debian, Mint, Ubuntu, Fedora, Red Hat, Oracle, CentOS, SUSE, Alpine, Arch, all kind of different Linux OSs. And this OS flavor gives us the flavor of the Linux or of the operating system. And then we have OS version and a description of the OS. And then we have a very important property, current, OS info current, that gives us an object of the current running operating system of one of those provider types for the operating system. That means on Unix it will give us this class here. On Unix it will give us an instance of Unix. On Windows 2003 it will give an instance of Windows 2003 of one of those providers here. So we can actually access a provider for the currently running system. And then so we can also get a Unix version. If we are running Unix, we can also get the Unix cast of the current operating system, or a Windows cast of the current operating system, if we know we are running Windows or Unix. Yes. Then we have another type that we introduced, that is shell. This is a class that provides facilities to call processes. You have the method exec that takes a command and runs this command either as a process or using a shell. And this is the async version. And then we have a sync version here. Just exec this command, and it as a return value it returns a shell value. This is not a task, it's a shell, but you can await on this shell like you could on a task. And then the shell has properties to get the output of the command, or the error output, or output an error. And there are tasks of things, so you can await on output or take output result in order to get the output of the command. And also the exit value, the exit code, it also returns a task you can await for, so you can get at the exit code of this shell object. And it also has logging facilities. You can add logging to this shell. It has those three events log error and log output, where you can hook upon in order to log the output, or you can just set the property log file, so the output is logged into a file. But I have to look at this log file. Let's quickly search for this log file. Here, this is just a string you can set, and then the log is written to this file. And then we have this one here, shell default. This is a static method, and this is linking to the current operating system's default shell. And this is the means how you get at the shell object. You don't call new shell, you always call shell default, and then it gives you the default shell of the current operating system. And then there's another method, find, here, and this method is just searching for a command in the current environment path variable, and it looks for this command in all the places of the path variable, and it returns the path to this command, or a null. When it returns null, it did not find the command in the path variable. Yes. So in the Unix implementation, it has implementations for the shells, and those are using shell as a base class. Actually, this implementation is very simple. It uses only the shell and defines the shell exe as bash, and this is shell exe as shell, so it can find the executable of the shell. And then we also have a class installer. Here we did, and this is an abstract class. It has a shell for executing commands, and then it can install apps and string of apps, and this string can be separated by semicolon or comma, and it will call the native installer installing all those packages. And also an async version, and add sources will add sources to the native installer, and it depends, the string of sources also semicolon delimited or comma delimited, and yeah, it adds sources to the installer. And this one here is it will check if the installer is installed on this operating system. And then you can also check if some applications are installed. And then we can delete applications or update the installer and the default installer of the current operating system. And so that's how we implemented support for the different installers. Like for example apt-get, this is used on Debian, and you can add sources to the sources list in Debian, and we can check for installed apps with this command here, or we can install apps here, apt-get install, and then it installs those apps supplied. Or like for DNF on Fedora, it installs with DNF those apps. So it's just an abstraction of the different package managers on Linux. And on Windows also we have an installer like this. This is WinGet. It's using WinGet as installer. And also Chocolatey, there's an installer for Chocolatey, but this is actually not very well implemented, I see, but yes. And then we have commands objects of shell for the shell, as before, for PowerShell and the command shell. This is for Windows. And then we have providers we implemented for Unix, like the Apache provider. It has a configuration section class for the Apache configuration, and this is a dictionary of configuration values, and it parses the Apache configuration, and then we have all the Apache properties that the config files of Apache support. All those properties we have here this is a partial class config section, and this is defining all the properties of the Apache config files, and then also the different types of sections of Apache config files. I think they're below here. No, they're up there. No. Ah, yes, those are defined here. Those are the different config sections that Apache config supports, like directory match, and those are config sections that support this. And if we use this in the Apache provider, these config sections, we have a method config that for a given site ID we just load the config file from the sites available folder in the Apache config path. With the given site ID we load this, and then we return config file load path. And then when you want to modify this configuration, like for example create virtual app directory, we load this config for the site ID, and we create a new location section in this config file. We configure the Apache properties of this config section, and then we look for the virtual hosts in this config file, and for all of the virtual hosts we add this location section, and then we save the configuration file and we reload Apache. That's how you modify those config files in the Apache provider. And this is for creating a website, and we are reading the bindings for this website, and this is a little bit tricky to configure the bindings, because for every IP address we need a virtual host section in the configuration file. And so we select the bindings here, and then we return a virtual host with host, server name, server alias, document root, and this is not yet complete, and then we save the configuration again. Yes, this is the Apache provider, and then there's another new provider for FTP. This one here, VSFTP provider. Also there's a class for the configuration file. This is a lot simpler than the Apache configuration file. Yes, and we have the provider here. But this provider needs to be improved. At the moment it's creating Unix users for FTP, and we need to change it so it's creating virtual users only for VSFTP that have no login on Unix. Yes. Those are the two new providers for Unix. Yes, so next, now we're gonna look at the installer, what we have modified in the installer. Installer we have him here. What we did to the installer first, we made a new installer that's called Universal Installer and Universal Installer Core in order to support the different Linux flavors. And this is Installer Core, and it has different installer classes for the different Unix flavors. This is the base class here, and it has different methods for installing prerequisites and everything. And it's a partial class, and we have here the server methods like install server prerequisites and install server, configure server, or all those methods here. And in the derived classes, those methods are implemented. Install server website, and on Unix it doesn't install on an Apache website but a systemd service to install the website, and it uses the service controller. It uses the service controller to install the service. And yes, we have all this kind of installers. And we have also for the UI of this new installer, there's a console UI. And for this console UI we have this class console form. It's a class that supports console forms, and you can have fields, and for the UI we have different it works like this. You make a new console form, and then you have this form here, and this with brackets, it's a password, and this is a button, and yes, that's the console UI of the installer. I don't know the syntax exactly of this console form. Actually, if you have a question mark, it's a text field, and with an exclamation mark, it's a password field. But there are different fields, like if you have a star, it's a default button, and there's also a progress bar somewhere. This here is a multiple choice with the X, and this is a progress bar with a person. And after the letter for the type of the field, there's the name of the field, and so you can just load all the values for those fields from an object that has those fields as properties or fields, and then you can save it again afterwards to the object, and it's reading those fields and storing them in this object. So you just load the form, and then you make show dialog, and then you save it again. That's how this works, this console UI. And there's also WinForms UI, but at the moment it's not implemented. All those methods, they are called by the installer in order to show the UI, and they're just not implemented at the moment. Only yes, the get root password this is implemented because it's needed by the old installer. This is the old installer here, installer core and installer. And in installer core, no, in the setup, this is SolidCP setup is actually the methods that get executed by the installer, and setup is downloaded together with the website, so in order it always is the newest version. So this has some actions there. We made a new class here, server units action manager, and this class it has different actions like install Unix installer. This one will install the Unix installer, so it can be called by this command here, SolidCP, from the command line. And then it has install server Unix, and this action, it actually uses the installer from Universal Installer Core. It just sets the setting variables, and then it calls this Universal Installer Core installer with those methods to install the server. And we have, yes, that's the server Unix action manager. And we have new forms for new wizards for the setup, the certificate page, because the servers need a certificate in order to run VCF message security or over HTTPS. The server needs a certificate, and this page here is responsible for configuring a certificate. You can specify a certificate from a store or from a file or with Let's Encrypt. And then that's this page, this wizard page here, and there's also a new wizard page, insecure HTTP warning. If you specify an HTTP binding, it warns you that this server only can be called through local area network, IP, or a local host, because it's not secure, the connection is not secure, and SolidCP web clients only support clients proxies over secure connections or local connections over LAN IP or local host IP. Or you can use a SSH secure shell tunnel to access only HTTP insecure servers. Okay. Yes. What is this? Modifications of the installer. If you look here, at the entry classes, like for example server. I think server, I'm not sure. Here we check if we are running on Windows. When we are running on Windows, we have the configuration check, and here's the configuration check for Linux. We check for the .NET 8 runtime and for systemd, and yes, it adds those controls, but so base, I think it's here in this class. Yes, it's somewhere here, install base. Yeah, so it's here in this install base, the distinction between Windows and Linux. Yes. Yes. Okay, in order to support the installer on Linux, we run the installer with Mono, because Mono support Windows Forms, and .NET does not support Windows Forms on Linux, so it cannot run the installer. So we run the installer on Linux with Mono. If you want to install SolidCP Server with the installer, you have to first install Mono, and then you can run the installer, and then you can install SolidCP Server if you install it with the installer. And I'm gonna show afterwards how you can debug with Mono in Visual Studio, because it's not trivial, as Visual Studio out of the box only supports connecting to a Mono debugger, but it's not really complete this support, and I'm gonna show this in the end. So let's have a look at the integration of Enterprise Server into Web Portal. This is achieved by this assembly binding that is calling an assembly instead of a web service. And how you can configure this is in the web config of the web portal. You can configure this. This is the web portal. This is the web config. Actually, because this website is running both. It's running web portal and enterprise server in one site, so it needs all the settings of enterprise server also need to be present in this web config of web portal. And in order to start enterprise server inside of web portal, you need to specify those external probing paths, and there we have the path to the enterprise server assemblies. They are reside in those two folders, bin and bin code of enterprise server, and if you specify those external probing paths, the enterprise server also gets loaded. And then you can specify what web services you want to expose. If you specify in the external probing paths also the path to the SolidCP server component, like this one here, you can also embed SolidCP server. And SolidCP server has a lot of probing paths, and you would need to specify all those probing paths in the external probing paths of the web portal. we have here all those probing paths here of the web config of SolidCP server, all those probing paths, and there's quite a lot. You would have to need to specify also in this external probing path in order to run SolidCP server also under web portal. And then you can say here expose web services. If you set this to false, then no web services will be provided through the web portal. Or you can only expose enterprise server web services, and then only the enterprise server web services are exposed in the web portal. Or you can specify server here, and then only server will be exposed to the web portal, or you can specify all, or like, yes, that's what you can configure here. Yes, that's how you enable embedding of the enterprise server into the portal. And finally, we have support for SSH tunnels to the servers, and this works like this. We can, if you look at the servers we have here, and this also works for the enterprise server that is configured in the web portal server URL. Also for this URL, it works also for enterprise server, but I'm only showing it for servers here. Yes. Yes. Yes, we have here the different server. Local host is the local Windows server, and we have here VSL Ubuntu. It's an Ubuntu server running on VSL, and then we have Ubuntu over an SSH tunnel. And if you look at this, you can specify a special URL, so it's connecting over SSH, and this is the URL. It starts with SSH, and then username, password, and localhost for the server connecting to the SSH client, and then a port number, and that's the port number that should be tunneled to on the server side. That server, the SolidCP server is running on that port, and so it will connect the SSH tunnel to that port, and so this way you can access the server over an SSH tunnel with this URL. You just have to specify username, password, and then a host, and then optionally an SSH port, and then the port you want to connect to. Because you need to specify the password here, this URL gets encrypted in the database. This URL gets stored in the database, and SolidCP will encrypt it. But still, it's if someone can get your web config file, then there's a chance he can decrypt this URL, and he can get at all your URLs for your servers and all the passwords for this SSH. So it's a security risk. Maybe VPN is more secure, because if someone hacks your enterprise server, it still cannot connect, but at least the password is encrypted in the database. So in order to hack the password, someone needs to get at your database and at the encryption key that's stored in the web config. Yes. Okay, that was it. Thanks for watching. One thing I forgot to explain is in order to debug SolidCP installer on the Mono, you need to install this Visual Studio extension here to Visual Studio, and then in Visual Studio you need to configure it. It's here under the extensions menu, and in the settings you need to configure the debug script. Here I had to export my display, and then you need to run the Mono process with sudo because it needs to run under root. Because if you run it as ordinary user, it will show a dialog box asking for the root password and will start a new process with root, but then you cannot debug it. So in order to debug it, you need to run it with root as root. And then here you need to specify the path to the SolidCP installer exit in VSL. Then you need to save this script, and then you can debug the SolidCP installer, and let's try. And so we have here the installer running on the Mono in Linux, and then we can look at the available components. And here we have SolidCP server. On Linux you only can install SolidCP server, and then we can install it, and now it's gonna download. So we skip this. Then we have this screen here, and when you start SolidCP installer with the debugger attached, it behaves slightly different. It does use the local setup DLL and not the downloaded setup DLL. So in order you can debug the setup DLL. And also it does not use an app domain for loading the setup DLL, but it loads it directly so you can debug it. So this is the welcome screen of the setup wizard. This is all as it was, and here are then the system configuration check. Here is specific for Unix. It's checking for Unix operating system, for the .NET runtime, and for systemd. Currently only systemd systems are supported, and then we can specify an installation folder. So we will use this folder, and then here we can specify the connection settings of the server, and here is the connection URL, and if we specify a host name, and this host has a public IP, not a LAN IP or a local host IP, the server will use HTTPS. So if the server is publicly accessible, it will use HTTPS. On Windows, it will still use HTTP, but it will use message security encoding with the VS HTTP binding. So on Windows, it will always use as HTTP, but on Linux, it will use HTTPS for a publicly accessible web service. So next, we have to configure. A certificate in order to use HTTPS and for VCF to have a secure binding. Here you can specify a file with a password, a certificate file, or you can choose a certificate from the store, or you can use Let's Encrypt to get the certificate, or you can choose manual configuration. And then we have to specify a password for the server, and then it's installing the server on Linux. So now we have installed it, copied the server files, created the systemd service, SolidCP server that's running the website, and the firewall was open and file permissions set and configured the server, and also the installer was installed. You can run the installer by this command SolidCP. So now the server is installed, so we can go in Ubuntu. You can close this. So here in Ubuntu we can always start the installer with this command in Ubuntu. And if you don't start it as root, we have to enter the root password in order to start it. And here we go. So that's about debugging SolidCP installer on the Mono.